everyone. Thank you so much for joining us for the launch of Powering Prosperity, Transmission, and America's Industrial Golden Age. We are so excited to launch this report today, and we really appreciate you spending this time with us. And we are even more excited to have a number of expert speakers with us today, who I'm sure will lead us into a great discussion on this really important topic. I'm going to start by introducing the speakers before I lead into a brief overview report of the report itself, and then we will have a moderated discussion followed by audience Q&A. So without further ado, Hollie Mitchell joined Steel Dynamics in 2016 and currently serves as the manager of clean energy procurement and carbon accounting. In this role, she drives the company's transition to sustainable energy, leading a portfolio of various energy projects while engaging with developers and utilities to secure cost-effective, emissions-free energy products. Thank you for being here, Hollie.
Thank you for having me.
Matt Aboud is the Senior Vice President of Strategy and Business Development at Century Aluminum. Prior to joining Century in 2021, he worked for the Norwegian aluminum company Norsk Hydro for 18 years, serving in various commercial and strategy roles at that time. Matt, thank you for being here.
Yeah.
Patrick Whitty is the Senior Vice President of Transmission Public Affairs at Invenergy, America's largest privately held independent power producer and a leading United States transmission developer. He leads the company's communications and public engagement strategy around transmission. Prior to Invenergy, Patrick served as a White House appointee and on presidential transmission committees where he advised on energy policy, including national security vulnerabilities in the U.S. energy supply chain. Patrick, thanks for being here.
Thanks, Danielle.
Wonderful. Okay, so with that, we will begin our presentation. If you could open up the slides, thank you. So again, welcome to the launch of Powering Prosperity. This is a report that we at SAFE worked really hard on. And it is, a report centered around a really central question of, can the United States power AI expansion and industrial regrowth at the same time? What's the answer to that question? And what needs to shift to make sure the answer to that question is yes? If you have not already, we invite you to download the report via this QR code, or I think we'll also be sharing a link in the chat if we haven't already. That's a direct link to the report itself. And yeah, we hope you will read it, share it. We made it short. It's an easy plane ride read. And it's really meant to be a conversation starter, right? So we're really looking for those on this call, those who work on these issues, to take this information and continue this really important conversation. Really quickly, for those who aren't familiar, a bit about SAFE and the Center for Grid Security. So SAFE is an action-oriented, nonpartisan organization committed to transportation, energy, and supply chain policies that advance the economic and national security posture of the United States, its partners, and its allies. Since 2005, so for 20 years, SAFE has worked with its Energy Security Leadership Council that we often refer to as our ESLC. They are a peerless coalition of current and former Fortune 500 CEOs and retired four-star admirals and generals who support secure, resilient, and responsible energy solutions for the United States. The Center for Grid Security at SAFE is one of SAFE's several centers that work on key issues in support of our mission. And our goal is to serve as a national hub for energy expertise and strategic thought leadership that places economic and national security at the center of grid planning and policy. Through focused education and engagement, we equip policymakers with the insights they need to unlock domestic energy resources, strengthen grid reliability, and meet the rising demand for affordable, reliable power. So this is a story and a chart a lot of us here are very, very familiar with at this point. Um, you know, and this kind of is meant to speak to the central question of the report. Um, for decades, flat demand in the United States has really well masked some of our energy challenges. And, you know, the growth that we're experiencing now because of AI, electrification, and increasing industrial leadership is a challenge. But the core message here is that we are trying to power our economy using a grid that was built for a different age. And, the system was built not to support the strategic goals we have now as a nation. And in order to shift that dynamic, we examine several things throughout this report that aim to articulate some policy solutions to meet the challenge of today. You know, these are a few of the really great charts we have in our report that I think outline the core issue of grid constraints, right? Competitors gain an advantage through rapid transmission build out and rapid grid build out. And China's advantage is not just in their industrial policy, we have found. Their advantage is an integrated energy and transmission planning strategy that they connect to their industrial and national security goals. Sector after sector, as you can see on this chart, whether it be semiconductors, aluminum, autos manufacturing, or steel making, China outpaces the United States in output. And this advantage is really underpinned by a grid that was built quickly and effectively to meet their goals as a nation. And the consequences of this are, not just economic, but they're strategic, right? And they really outline that grid power is a competitiveness tool for a nation, whether they choose to recognize that in their policy or not. And this kind of outlines, the so what of the charts we just saw. So, and this is really where the problem becomes much more acute. When power is scarce or capacity is scarce, sectors compete within a nation rather than flourish. So, certain types of industry bids against each other for grid capacity. They create systems to jump interconnection queues better than other sectors, as they should, right? They're all just trying to lead and, get their needs met within the United States. But that scarcity really creates sort of a false choice, right? And it's a choice that we really cannot afford to make as a nation. And it's a choice that we don't have to make if we can shift our grid policy and the pace at which we expand capacity in the United States. And I would just, I highlight some of these headlines to note that this isn't a theoretical thing. I think when we talk about grid challenges, a lot of it is future looking, as it should be, that this will be an issue in the future. Um, these are challenges of today, and I think you'll hear a lot more about them in much better detail from our expert panel. But these are things that are happening now that are eroding our competitiveness as a nation because of a lack of access to power. So coming back to that, core question of the report and, with the grid we have today, with really the grid policy that we have today and our grid planning processes that we have today, can the United States dominate in AI and also lead in industrial onshoring, specifically for defense critical industries, which are the industries we outline in the report? Um, and we found the answer to that question to be probably not, probably almost definitely not. And determining that answer, we asked ourselves, okay, what is the main shift that we're seeing as necessary to change that dynamic? And this was informed greatly by a number of stakeholder interviews we did with members of those key industries, a few of which we have with us today, and kind of asking them, where are the friction points and how can we, you know, make it so that you aren't competing with your friends, but you are able to flourish alongside them. And that really led us to an answer of transmission expansion being a really critical piece of shifting the country out of a zero-sum game when it comes to access to grid capacity for large defense critical loads. And, you know, I think we outline here some of the unique benefits of transmission, and also in more detail in the report. But transmission does so much more than just move power from where it is to where it needs to go. It reduces system cost, it improves reliability and resilience, and, most importantly, you could argue is it delivers a number of ancillary services that data center loads or industrial loads cannot cost effectively meet, on their own if they were not to have access to transmission service. Um, but most importantly, if we look at what dynamic does expanded transmission capacity create for the country, it allows multiple sectors to grow at once simultaneously. It allows a number of large loads to come onto the system more quickly than they're able to today with today's transmission capacity. So kind of, okay, what needs to happen? We landed on two high level but important recommendations in this report. And these are, that first recommendation you will find in a number of papers written about grid power and national security. But that first recommendation is to expand transmission capacity. With a priority for high voltage and interregional lines. These are the lines that are most needed by large loads, and they can help us connect various grid regions. That is a really important piece of improving reliability and resilience for the country. And as you'll hear from our speakers later, that reliability and resilience is critical. And that was a very, very central theme throughout all of the sectors we spoke to. Our second recommendation is to publish a national reindustrialization action plan that places industrial expansion on the same national priority level as AI leadership. We are aggressive about AI expansion in the United States, as we should be. We're also pretty aggressive about AI policy at the national level. We give it a lot of love and attention, as we absolutely should. But there are a number of large loads aside from AI that are critical to our national security posture. And those large loads need the same focus in federal policy and need to be given, the same weight behind them when it comes to these policy conversations at every level. And to publish a strategy would really set a tone, right? An action plan sets a tone of this is a priority for the country. And these are the things that need to happen to, get us where we want to be. And in that action plan, we recommend that transmission be a central piece, as well as other energy requirements as they are in the AI action plan. So with that, I hope that you will, dig into this more. This is just a high level preview. And we will get into our panel discussion. All right, everyone. So I am going to start off with a bit of a round robin question for our speakers. We have a really unique group here than, different than I've seen on most calls. And I think there are likely transmission members of the audience who are maybe not as familiar with steel and aluminum and vice versa. So I think it would be really great for each of you to start and tell us a little bit about your industry and make sure you touch on what is your industry's connection to American national security, and make sure people in the audience understand why we feel so fortunate to have you here with us for this discussion. Hollie, we'll start with you.
Okay. So I'm from Steel Dynamics. We're the fourth largest steel maker in the United States. We have a circular manufacturing model set up. So we also own OmniSource, which is our metals recycling. And we also have some downstream businesses as well, New Millennium Building Systems that our steel goes into. Our Omni facility is the largest metals recycler in the country. And so Steel is a critical material for this nation. I mean, steel goes into almost everything, infrastructure, buildings, automobiles. I mean, pretty much anything that you can possibly think of. They need steel to make it. Also, in addition to, I know we're talking a lot about data centers and AI, those buildings that they're building have to be erected with steel. So it's a very important and critical material to this country for sure.
Thank you, Holly. Matt, I'll have you go next.
Sure, yeah. So I'm with Century Aluminum. We are actually the country's largest producer of what we call primary aluminum. Primary aluminum is aluminum that's made from the ore that's mined from the ground. So we start with bauxite, and bauxite is then refined into alumina, which is really aluminum oxide. That's how it's found in the native state in the earth, and then we smelt it into aluminum. One of the great and unique attributes of aluminum is that it's very recyclable. So there's a very large, what we would call secondary industry as well, where you're recycling aluminum into new shapes and forms. But to be clear, that's not what Century does. Century is only on the primary side. And that process is extremely energy intensive, which we can talk about in a little bit. But much like steel, aluminum is an important material for all sorts of uses. It actually was deemed by the USGS a critical mineral. So it's one of about 30 critical minerals. And it plays a very large role in the military and defense industrial base. It's light, but it's strong. So think about weapon systems, things that fly in the air that need to be very robust. But then, of course, we also are in things like the high voltage transmission cables that we're talking about here today, carrying that electricity, as well as other what I'll call critical civilian industries like the aviation industry, airplanes, and automobiles. So much like steel, aluminum is a key material for the prosperity of our country and of the world.
Thank you, Matt. And Patrick.
So Danielle, our company, Invenergy, is North America's largest privately held independent power producer. Energy is more complex than ever before, and we transform that complexity into solutions that power our customers' operations. Invenergy is truly all the above. We have successfully developed over 220 power plants, including natural gas, solar, land-based wind, and energy storage. Our portfolio that we operate is over 20 gigawatts. And today we're also developing transmission lines to address the challenges you spoke to in overviewing the report. So an easy way to think about Invenergy is we make and move electrons. And, the US electric grid has, since the early part of the 20th century, been a critical asset in supporting national security mobilizations as early as World War I. But today it's incredibly difficult to build new grid infrastructure, whether that's generation or transmission, and I would say especially transmission. Meanwhile, if you look at China, China now has the world's biggest power grid. Between 2010 and 2024, its power production increased by more than the rest of the world combined. Last year, China generated more than twice as much electricity as the US, and some Chinese large energy users are now paying less than half what American ones pay for electricity. So when you think about how essential electric power is and how fundamental it is to American long-term economic growth and global competitiveness, we really just have to start evening those scales.
Yeah, thank you for that. And those are some really sobering data points that came out very recently. And I think those of us who work in energy really feel that that's important to know and to note. So thanks for sharing that. I'm going to move to a question for Holly and Matt. One thing that became very, very clear to us, in the making of the report, but we knew about before, and I think a lot of us have heard here, is that your two industries basically need around the clock power. And you need a lot of it, and when we say around the clock power, it's like, is that an exaggeration? How much do you really need? What is your tolerance for downtime? Could you both give us some more detail about the energy needs of your industries? And, how detrimental is a loss of power, even a brief one, to what you're doing, whether those be financial, safety, or just production impacts. And, you know, Holly, again, I'll start with you.
Sure. Yeah. So we are a primarily EAF steel manufacturer. And for those of you who don't know what that means, it's an electric arc furnace. We essentially have three inputs that go into the furnace. We have scrap, which is where our omni-source operations come into play, anthracite coal, and the biggest component is electricity. I like to compare it to you're making Christmas cookies and you've got your big blender and you put all your ingredients in, you mix it up, and so you turn it on while you're mixing it, but then you shut it off and you pull all your batter out. Steel's the same way. You throw everything in the furnace, but you'll eventually flip it off and turn off that electricity, and you'll cast it and send it down the line to do everything else that we need to do in the steel industry with it. And so we're peaky is how we kind of describe that. When the furnace is on and we're melting, pending what's on down the line as well, we will shoot really high in our demand. But then as soon as that furnace comes off, we'll drop back down. Again, it depends on what else is running through the mill as to what levels we're operating at. But we aren't, for lack of a better term, a toaster where you kind of plug us in and we just sort of hum at the same level all the time. But we do operate 24/7. We run 4 shifts day in and day out. Really, the only time of the year we shut down is Christmas. We're always up and running. And so to have a power outage, not only obviously is there a financial impact to that because we can't operate. If we can't operate, we can't make steel, we can't sell steel. So that's a big deal. But I think a bigger component to that is the safety of our employees. If we were to have power outages and we're in the middle of melting steel and making that, and that furnace is on, it creates a very hazardous situation for our employees. And so reliability is a huge factor and a huge component to our operations for sure.
Yeah, thank you, Holly. And Matt, what about you? Tell us about aluminum.
Yeah, well, our process is a little bit different in that we're not peaky. We operate at a very constant level, 24/7, 365. I mean, just as an example, our plant in Seabury, Kentucky was started up in 1974. And so it's just over 50 years old now. And there hasn't been a day since then when we haven't operated at full production. So the worst thing you can do in an aluminum factory is turn the power off. So in terms of our the impact, if we lose power for even an hour, we'll have major disruptions because the process of aluminum making is what you're doing is you're actually using an electrolytic chemical reaction. So electricity is not just powering machines or generating heat. It's actually used in the process to separate the oxygen away from the aluminum and make molten liquid aluminum at 1,000 degrees Fahrenheit. So the issue is when you lose power, that red hot aluminum starts to cool and starts to freeze up. So imagine 10 football fields laying down next to each other with lots of different, we call them pots, but just think of chambers where we're making molten aluminum. If those things cool and freeze, the operation is basically ruined. You have to go in with jackhammers and jackhammer it out and then reline the pots for the cathode materials and anode materials that you need. So after about 4 hours, the whole operation would freeze up and would require a considerable amount of capital to restart. But even after 1 hour, we have disruptions where we'll get out of our normal operating parameters and we'll lose some rows of pots. So for us, reliability is everything. And of course, to echo with the safety issue, of course, if you can imagine with red hot molten aluminum around, if suddenly there's a power loss, it does put our employees at risk. So we put a very, very high value on continuity and on grid and power reliability.
Yeah, those are really important, pieces of the picture when it comes to the impact on your production and of course the impact on the safety of your employees. I'm curious though, can you tell me a little bit more about cost? Like, if someone were to offer you really wonderfully reliable power, but you had to maybe pay a premium for that, would that work for you, or why not? You know, what does cost of energy mean to your industries?
Well, I'll answer that first. I mean, of course, reliability is a must. You know, we just cannot operate in an environment where we're losing power or having outages. You know, I'm not the electricity expert in my company, but I'll try my best to sort of sound intelligent. You know, so basically in our regions, you know, power is broken into a couple different components, right? So you have the actual power, you have transmission charges, you have capacity charges. And, you know, we're based on that graph you're showing where demand is surging, we're running into risks that suddenly there won't be enough capacity under a stress case. So really hot summer, a very cold winter, and you know, so there is a capacity charge. So in a way, we pay for that reliability. We do pay for that reliability through a capacity charge. And because we're a very large user, we're able to register as an LMR, a load modifying resource, meaning we can bid in during those capacity auctions how much we can modulate or how much load we can shed, and we can get compensated for it. But that's a very risky step because if they actually call on us for that demand response, as I mentioned, we don't have a lot of grace before we're in trouble. So actually what we have to do is we have to buy our way out of it. And that's very, very expensive. But again, the alternative is potentially a major cost event in a shutdown. So, you know, to answer your question, we're going to pay for that reliability one way or the other, either through a more robust grid and more generating capacity, or through these capacity auctions where we're basically going to pay a penalty if that grid is not reliable.
Yeah. Holly, do you have anything to add?
No, I think I agree with pretty much everything that Matt said. I mean, reliability is key. It's extremely important. I mean, I agree with everything he said from a safety perspective. It's the same way with steel. When you've got molten hot steel that you're melting and getting ready to pour, I mean, even a very quick blip in that reliability can be detrimental to our equipment. But and again, the safety component of it, we strive for keeping our employees as safe as possible. And so it can get risky. And then I agree too. I mean, you've got the costs that we are already paying in the different elements of our bills. But bear in mind, and I'm sure it's the same way with aluminum, as those costs continue to increase, it forces our operating costs to go up, which is going to force the cost of steel and aluminum up. And then everybody who's buying those components are going to start to feel those expenses as well. And so it's in everybody's best interest to try to keep that cost down as much as possible while maintaining that reliability.
Yeah, those are great points. So, Patrick, when, you know, we understand the reliability needs and the cost concerns of these two industries we're talking about here, from your perspective, you know, why is transmission so important to talk about as a solution set for that? You know, why aren't we just talking about generation, and kind of what does transmission uniquely provide when it comes to cost and reliability from your perspective?
Sure. So I think when we talk transmission, it's important to differentiate between different types of transmission projects and the different values that they bring. So most commonly, transmission in the US is built within regions or so-called intra-regional transmission. And then in contrast, you have lines that connect multiple grid regions or interregional transmission. There also is differences in business models. So the vast majority of transmission in the US is built through a traditional ratepayer funded transmission planning processes that are led by the grid operators. And then you also have private sector led merchant transmission projects that are independent developers pulling together private parties. And then there's also different technologies. So most transmission in the US, most of the grid relies on alternating current technology, but there is high voltage direct current transmission that has, especially unique reliability advantages. So we need all those forms of transmission to expand the grid, but they're not all created equal. And I think just as one example, Invenergy is currently developing the largest transmission line in the US, which is the Grain Belt Express. That is an interregional HVDC merchant project. It'll connect 4 different regions of the US grid over a span of 800 miles and unlock an equivalent of 5 gigawatts of new energy supply. So moving enormous amounts of power, long distances, and that tying it back to national security, over 25% of Department of Defense installations are located in the grid regions that are served by the project. And the HVDC technology can have, the converter stations that are at the start and the middle point and the end point of that line. If you think about it like the laptop charger that you might use or the phone charger that you might use, the little box on that charger is taking electricity and transforming it from the alternating current form that it comes from in your wall socket and delivering direct current to your device. That process basically allows not only power to be moved across regions so that you have sharing of all of the different assets that are in regions that are connected by these lines, but it also creates an interface that if there are irregularities in power on one side of that exchange, it smooths it out and helps deliver some of that power quality and power assurance that both Matt and Hollie spoke to.
Yeah, thank you for that. And just, I think you touched on it quite well already, but just to make sure it really comes across for those listening, one of the key points in our report is that a lack of transmission capacity sort of creates this unhelpful artificial competition between industries that we want to all win in the United States collectively, not one ahead of the other. How does additional transmission capacity uniquely help solve that problem and kind of get rid of that false competition that we're seeing?
Well, for a lot of years on the grid, when we had flat load growth and we had it's been difficult to build more transmission for some time now. So under those conditions where you have flat load growth, there truly is a zero-sum game of one energy source is going to come at the expense of another energy source for shipping power across the same network. So there's that zero-sum game on the generation side, and it's similar on the load side or the demand side. And growing the number of networks for power delivery is essential for both adding new generation that's required to increase supply and also enabling multiple large loads of different types to have access to that power. So, we have faced congestion as a major challenge on the grid. So you basically have a grid today that has a whole bunch of traffic jams trying to get power from one place to the other. And if we're not addressing those traffic jams, the ability to add more cars to the road, as it were, is going to be constrained. And when you have that congestion, it comes in the form of higher prices for consumers. So it's not only a reliability issue, but it's an affordability issue, which is so in focus right now.
Yeah, that's really important to understand. And when we talk about all these challenges and the traffic jams and things like that, co-location is something that we hear about a lot. I mean, we've been hearing about it for a while, but it seems like more and more as, Hollie and Matt, a solution for your two industries specifically to kind of get what they need quickly, cut through all the grid challenges and just kind of avoid the whole thing and start to build and grow and function more in the United States. And, in the making of this report and in other conversations, we're lucky enough to have it safe, but we've heard, not you two, but really your whole industries kind of say, that's not the right solution for you, and you'd really like transmission service. Can you both speak to why that is a little bit? And Patrick, I also invite you to add your perspective on the co-location as a solution, over transmission expansion. Hollie, do you want to start?
Sure, I can go. This is a conversation that I actually have quite often. So co-location is tricky because like I've said, we're peaky. So it's not a one size fits all sort of solution for us. There are different technologies where it can help us in delivery of energy. But there is no technology that can be peaky in their generation along with our consumption that can match that profile, I'll say. So there's a small generation that we could attach to a facility, but we're still going to have to go out to the grid to pull additional in to fill in the gaps. Or there's other technologies that you can choose that generate tons and tons of electricity, but there are times when we can't use all of that. So there's going to need to be transmission to send that back out onto the grid as well. So I think ultimately, regardless of a co-location, regardless of the technology, we're always going to have those transmission lines in and around our facilities, whether it's to pull or push or both. And then in addition to that, you sort of don't want to put all your eggs in one basket either, right? Like, pretend like SMRs are a hot topic right now, and pretend we're going to put an SMR behind one of our facilities. That facility will have to come down at some point for refueling, and then what? We have to operate. So you're always going to need that attachment to the grid to pull power at various points in time. So it might be a component to the whole story, but I don't think it's going to solve all of the issues that are out there.
Yeah, that's a great point. And I loved what you said when we spoke about this before. Not to share it, incredibly broadly now, but you basically shared that in the United States, the steel industry is really, really good at making steel.
We
And
are.
you want to continue to be able to focus on being really, really good at making steel and not, being pulled in the direction of broader power management.
Yeah, I mean, I think ultimately at the end of the day, whether we did a co-location or not, it wouldn't be us building that facility. It would be us partnering with a utility to potentially build that facility. To your point, we make steel and we make steel very, very well. We don't want to be a utility. So let the utility companies do what they're good at and let us kind of do what we're good at. And so there's that component as well, where you have to partner with somebody else to co-locate something.
Yeah.
Yeah, I'll echo a lot of what Hollie said. In addition to just wanting to make aluminum, a utility also usually has a stronger balance sheet than we do. So for them to finance and construct a billion-dollar asset, they're better suited to do that than any industrial player. But look, actually, aluminum is a little bit different than steel in that it is not peaky. So in a way, we do set better for that type of a co-location. And in fact, many aluminum smelters are co-located with a generation source. But so while there are some pros, there are also some cons. One of the cons is a bit what Hollie said, is that you are then very reliant on that one source. And so if something happens to that source, whether it's planned or unplanned, you still need to maintain a connection to the grid. Secondly, another big little hidden cost there, of course, is depending on what the fuel source is. If it's a fossil source, so let's just say likely in this day and age, a co-location would be some sort of combined cycle natural gas facility. You still bear the fuel risk. And if you go back to 2022, after the Russian invasion of Ukraine and natural gas prices spiking, that would have dramatically changed your energy cost picture if you were, not diversified at all. And then, the other thing is that, of course, you do need a little bit of flexibility. So maybe that's a bit like Hollie's peaky point, but let's say you want to do an expansion. If you are maxing out the generation of that co-located source, then where are you going to get the extra power from? These are not facilities that you can generally just step up 10%. It's binary. Either you build a whole second unit or you don't. So look, we would prefer to be a customer of a utility with a deep and robust grid with diversified sources of generation. and have all the redundancy and flexibility that comes along with that. So just again, pros and cons, but given all those different factors, our preference would be to just be a reliable load to a grid provider.
Yeah, that diversity is such a great point and a unique benefit of transmission service and grid connection. You want access to the gas, the nuclear, the geothermal, the hydro, others, of course, to kind of, like an investment portfolio, hedge your experience. Anything to add, Patrick, on co-location and transmission service?
Hollie and Matt both spoke to it so well. So I think as a company in the grid space, what we would add to that, I think, are just when you think about the stuff that's expensive in a power system, it's the capacity or the power plants you have to meet your baseline energy needs. It's the fuel to run those plants, and it's some backup to make sure that when things go wrong, you've got enough to ensure reliability. So the role of interregional transmission there is to allow each of those to be shared across a much wider physical footprint. And I think as we've seen more threats, especially of severe weather, that can, knock off many different, there's really no form of energy generation that's impenetrable from severe weather events. And so you don't want to ever have your concentrated geographic risk. And the more you can spread that out, the better. And I think both Hollie and Matt mentioned kind of both pros and cons to co-location. When we are able to, move forward more interregional transmission in the US, those hubs where the grids can share power end up becoming very robust points in the system. So those are actually ideal points to locate both large loads and new generation. So it kind of is a both and opportunity. But I think the more you can be sharing those resources and spreading the risk, that's sort of in line with the history of grid integration, and we just need to continue that across the existing regions that are today.
Yeah, I think the both and is a great point. I want to kind of go back to something that Matt mentioned in his overview of the aluminum industry. Patrick, we've heard about basically how important what you do is for steel and aluminum, but I think it would be really cool to hear from you, like, how important are steel and aluminum to what you do at Invenergy, and does it matter to you if you can get that steel and aluminum domestically? Tell us a little bit about the other side of the coin here.
Yeah, I mean, I think there's a huge opportunity for a virtuous cycle in the US in US grid expansion, because the physical infrastructure of the US grid pulls so heavily from steel and aluminum. So every time we build a new transmission line, we have need for those materials. And then once that line is built, it's creating more affordable, reliable power, which is the need that Hollie and Matt have both spoken to. So just as one story along these lines, with the Grainbelt project that I mentioned, Invenergy entered into a supply agreement with a company called Prysmian North America that manufactures conductor, which is the metal line that the power actually moves along on a transmission line. They have had there's a factory in north central Pennsylvania that has been in operation for nearly 100 years. And we helped Prysmian, because of our supply agreement, expand their production capacity at that facility. And the first order that we've committed to for Grainbelt Express, which will supply the entire conductor required for the project, is sourced from conductor that will use 100% steel, 100% US domestic steel and aluminum. So it's a great example of, you have a factory expansion that's employing more Pennsylvania workers. You've got a factory that's going to produce for a US transmission line that will deliver billions of dollars of energy savings, including for the region that factory is located in, the PJM region that serves Pennsylvania. So they're going to have more energy assurance and reliability as a result of the product they produce that supplies the transmission line. And I think the more we can, from a development standpoint, the more we can work with domestic suppliers, the more we can be close to that supply chain, the more project management assurance we have. And I think there's always always preferred when you can do that.
A great story. I'm gonna move quickly to our closing question because we have some audience Q&A already rolling in, and I want to make sure we have time. Just in closing, all the wonderful comments and perspective you've given today, thank you so much. What, are we still missing in policy? Kind of what is like our most meaningful next step when it comes to policy, for the things we spoke about today and the things that are important to each of you? And I won't start with Hollie this time. I'll start with Matt. Yeah.
No problem. Listen, I think we're talking about it here today, is that we need some sort of a national policy for energy consumption for large users. We're getting a lot of momentum for that on the AI side of things, the data center side of things, because the administration has realized that this is a game-changing technology and a critical period where there's a race to take the lead. And we view our adversaries as attempting to also establish themselves as a leader in the space, and we want to win that race. So they're already examining policies that would incentivize and speed the adoption of these data centers. But let's not forget the other large industries that are industrial, that are manufacturing, that are critical industries for the country. So there's a lot of different ways to skin the cat, and I'm certainly not a policymaker, but we would look at something like these, like we have today, a Section 45X in industry tax credit, production tax credit, something like that, something where, in other words, we can try to incentivize, well, number one, incentivize the producers of energy to sell to people other than the data centers. And then number two, for the consumers of that energy, let's give them reliable, affordable, and abundant energy. And if you tie that to their usage or the energy consumption, I think there's a way in which we can accomplish these goals, but we just need to have some sort of national policy. When left to the open market in all these different state by state, utility by utility regions, you're going to get, unfortunately, what we've gotten, and that is a big competitor in China with a strong central government, with lots of subsidies and lots of state-owned support, just completely destroying our industry. And whereas if we're doing something that's not critical to national security, then the economists out there might say, oh well, that's just a better allocation of resources, that that country's better at it than we are. But when it's a industry that is critical to national security and our defense, we don't want that to go away.
Exactly. Well said. Hollie, Patrick?
I can build on that. I
Yeah.
agree wholeheartedly. I also think that there needs to be more collaboration between not only the federal government, but state and local as well. It feels a little disjointed right now that the federal is starting to, make policy, but maybe the states and locals aren't necessarily on board. So I just think that there needs to be, there's not a one size fits all for sure, but I think there needs to be more players at the table. To Matt's point, it feels like there's a lot of AI players at the table. I think that there's other large manufacturers that should be there as well. But then I think that it's not going to just be the federal government that's going to need to be in there helping. I think that the state and the local officials are going to have to get in there and help in addition to.
Great point. Patrick, what are we missing in policy today?
Well, Danielle, I think speaking to the interregional transmission issue specifically, the North American Electric Reliability Council, or NERC, did a study called the Interregional Transfer Capability Study recently. And one of the key takeaways from that study was that every region they looked at in the US showed energy deficiencies under extreme conditions, and that the US needs 35 gigawatts of new interregional transmission. But right now, we do not have a requirement for that interregional transmission planning to take place. There's no authority charged with that. So I think addressing that challenge is one. I think when those interregional lines advance, making sure that they are given credit for the capacity they bring. And I think obviously there's a lot of talk about permitting reform. We certainly believe and support the National Environmental Policy Act, the Endangered Species Act, other cornerstone legislation like that. I think the laws are not fundamentally flawed, but their implementation can be a pervasive hurdle. So we need to make sure there's clear regulatory language, limited scopes of review, and adequate agency staffing to make sure that projects can move through those reviews in a timely manner.
And that leads us perfectly into our first audience question for you, Patrick. I'll read it to you now. So much of this discussion ultimately comes down to the dreaded permitting reform debate. How has Patrick managed that process for Greenbelt Express? And are there any lessons learned, best practices that you've taken from that when it comes to permitting?
Well, I think just to give an update kind of on where things stand on our project, Greenbelt went through a multi-year NEPA review process, and as some folks may be aware, there was a decision made this summer on the Department of Energy loan guarantee that had been secured by the project. That loan guarantee was basically canceled over the summer, but in conjunction with that action, the Department of Energy moved forward and issued the final environmental impact statement for the project. So I think that provides a strong permitting record moving forward for the project. I think it'll have to be on a separate permitting pathway. But I do think there's been a lot of talk about just providing assurance and consistency for energy infrastructure developers. And these projects require years and billions of dollars worth of investment, especially when they're being advanced on a private sector business model. And developers just need to know that when there are final decisions made, that they can trust those decisions and that there's policy certainty. So I think that's a huge piece of kind of going back to my comments at the start of the call of we've got to level the playing field with global competitors. And if developers in this country can't count on moving projects forward based on a certain set process, then that's going to be makes it even more challenging than the task is already.
Yeah, keeping projects investable is such an important piece of grid expansion. So that's a really, really great point when it comes to permitting or just really even bigger picture policy for the grid. Thank you. I believe this is another question for you, Patrick. What is the typical difference in kind of cost per mile for new HVDC in the US compared to other types of transmission? That's a very specific question, but I don't know if you could give us a better picture of like, yeah, that's very specific.
I don't know that I have that offhand.
Yeah.
I would say there's across different generation and transmission areas, you're seeing a lot of supply chain pressure, whether it's the timeline and cost to secure gas turbines for natural gas plants, or what is basically a global rush to deploy HVDC technology, or even high voltage 765 kV AC technology. So all of those have challenging supply chains that we're obviously. I think that's a big reason why any available energy source, and especially ones that can be deployed quickly, are so vital right now.
Yeah, and I will probably get this wrong off the top of my head, but I believe that the data point is over 350 miles. HVDC transmission typically has a really, really great return on investment. And I would encourage the person who asked this to look into it more or reach out to me and I can help get them an answer. Okay, another question. Does data center growth support or conflict with the goal of revitalizing American manufacturing? And how should policymakers think about integrating this load? I feel like we've touched that high level. I think, before I turn it over to responses from you guys, I apologize. we do feel that we see it conflict now, but it's not because it wants to conflict. It's because of the scarcity of the grid system that we have in the United States. So I feel really strongly, and the Center for Grid Security feels really strongly, that these two strategic goals for the country of industrial revitalization and AI dominance are not in conflict with each other. They are two goals that we must achieve as a nation, and it will take national policy to achieve national goals of any kind. So I think the point there is we want to make they are not inherently in conflict with each other, though it seems to be that way, and it's a policy issue. It is not an issue with these two industries, is something I would really strongly emphasize. Anyone have additional thoughts on that?
Yeah, I mean, I think I agree completely. I think as a whole, we want the AI industry to succeed, absolutely, but not at risk of other industries. Like
Right.
we need to make sure that we're building up everybody at the same time and we're not focusing on just one over anybody else, because ultimately, as we've all said, they all work together. AI needs steel and aluminum and steel. We're going to utilize AI for sure. So it's all circular. We just need to make sure that the focus is across the board and not just solely on one piece of the puzzle.
Yes, it is circular. That's such a great point. And like the way I look at it sometimes is like these are your customers in a lot of ways, you know. So
Absolutely.
you're
Yeah.
not certainly
Yeah.
in the business of competing with your customers.
No, not at all.
Yeah. Any additional points on that? All right, we'll move to the next one. The report emphasizes national security implications. What role should the Department of War play in prioritizing or enabling transmission development? Patrick, do you have any thoughts on that?
I think there are, when I talked earlier about the potential for a interregional transmission planning authority, I think there are a lot of different parts of the federal government that have an interest in this. So potentially there's a role there for Department of War in some of that grid planning, because they obviously, I think, have a very good sense of where the defense critical facilities are. And I think also as a advocate in some of these RTO processes. So I think the federal voice on issues of national security can be really important and impactful when underscoring to regulators just how critical some of these planning efforts and facilities are for the national security needs of their footprint.
Yeah, that's a great point. And I'll just highlight for this person as well. There is a transmission provision in the NDAA this year that really is aimed at helping the Department of War, or understanding the Department of War's experience in transmission constraints or what they need from the transmission system. And I think that is hopefully going to be a really great start to them articulating their needs. What do they need from transmission or not need, but I'd be surprised if they don't have quite a need, because they are big energy players, as they should be. Okay, great. I think we have one more. What are the realistic consequences for US competitiveness if the country does not expand transmission? So I guess if nothing changes, can you, and I feel like this is a good one for Holly and Matt, what will that mean for your industries? Kind of paint that picture for us.
Well, I can only just tell everyone who isn't familiar what's happened to our industry over the last 20 years. So as recently as the year 2000, the US was the largest producer of primary aluminum, and we had something like 22 or 23 operating aluminum smelters. The competition for energy and the rising cost of power, along with the existential threat of China coming in with their state-owned enterprises and their government subsidies, Currently, we only produce about 1% of the world's aluminum, and we only have 4 smelters left. So this has been a terrible story of how an industry that is exposed to free market and capital constraints has been close to being destroyed, and we've had nearly an extinction event. And the only way that we get back is through the expansion of our power systems. So we need more generation, we need more transmission, we need it abundant, we need it affordable, and then because the market is still here, the demand for aluminum, and I'm assuming the same for steel, has not declined. It's grown, but yet we can't produce it on an even playing field with China. So I can only forecast that if we don't take those necessary steps here over the next 10 years, my industry won't last.
Well, oh, go ahead, Hollie.
I was just going to say, I echo that. I mean, I think, as we Steel Dynamics attempt to grow, one of the very first things that we look at is the reliability of the grid in that area of the country, and that has a very key component on our growth. So it's critical. It's critical.
Yeah, I think we will close on those incredibly well said points. I want to thank each of our speakers again for your time and your insights. We so appreciate it. And thank you everyone for attending, and download the report, reach out, and have a great week. Thank you.